Okay, I am recording with my other software.
Oh, perfect. Just hold on until I start talking.
Sure. Yes. When I open RStudio, um, I want to first set my working directory to whatever folder I have the data in. So um, I'm going to start by setting my working directory. And this is one of the only things that I don't do only with code. This is one of the things that I do through using the menus in RStudio. And the way that you set, so in your case, when you go to do your exercises, you'll have a folder that has your data for this workshop, and you're going to go to that folder. So you're going to go down to this window, make sure you're clicked on the Files tab, and you're going to find this little dot, dot, dot over here on the right. You're going to click on that, and you'll be able to go to whatever directory you want in order to set your working directory for your session. So this is how you connect R to your computer. And I'm going to go to my ADA folder, and I'm going to go into the folder for this workshop, and this is where I keep my data. So I'm going to click Open. Then I'm going to go to this little gear right here that says More Settings, and I'm going to say Set as Working Directory. And what that did, it set this as my working directory so I can easily get to all of the files in here. But you can see it also created a command in my console over here. And this is instead of just because when I work, I want to save everything so I don't have to do anything again from scratch. I'm going to take this from the console. I'm just going to select it. I'm going to copy it, and I'm going to paste it into my syntax window. And this is going to be the first line of code in my program. Okay. So I'm going to go ahead and save this. I'm going to say save, and I'm going to save this as 2023. I'm going to save this as a .r file. So when I open this again, it will open automatically in RStudio, and I can start, instead of having to actually go to my working directory and do all the things I just did, all I will have to do is run this one line of code, and then I'll be able to access my data right away. One other thing I want to show you about working in R that's very important for me is you can make comments in your R syntax as you go. And the comments can help you remember what you did. So if you're new to programming, it's very important to make comments on your program. So one reason for that is just because you may not always remember why you did something when you go back to your program, especially if some time goes by and you open it again. But if you're going to share your program with other people, it will help them know what you did as well. So in R, you make a comment by using, it looks like the hashtag or the pound symbol. There's different names for that, but that makes a comment. So this is a comment. And everyone has their own way of commenting. I like to put 3 of those in a row before most of my comments. And I'm just going to say, set the working directory. So now I can remember that this is what I did to set the working directory before I got started. So those are a couple of very important things that we've already seen in R. So one of those is how to access your data easily and to set your working directory. And another one of those is how to make comments in your syntax as you're programming. Okay, so now we're going to go on and I'm going to actually show you how to read in your data. So there's two kinds of files that I work with a lot. One of them is a CSV file, and this is a spreadsheet. So I actually think maybe I should open this file directly so you can see it. Okay. So we're going to work with a data set called the Madagascar data set. And this is what this folder looks like in my computer. And I'm just going to open this file really quickly. So this is what I'm going to be working with, but I'm going to be using it in R. And so it looks very similar, whether I open the CSV file or the Excel file version of it. And what I have in here, this was a research project that one of my clients did, where they visited Madagascar and they interviewed a lot of people who had moved from a country area to a city area. And this big city there is called Vavatanina. And so they asked them a lot of questions, and in the end, we came up with some scales. So these variables are numeric. They're scales of things measuring how connected they are to their families back in the country. We have some ordered categorical variables that have to do with their well-being, how much financial capital have, how much human capital they have. So that's things like education and abilities. Material capital, which is how many things they have. Social capital, which is something like, do you have people who can babysit for your children while you are gone? And then we have some demographic things like gender, age, how old they were when they migrated to the city, their reason for moving, their level of education. And so the reason I like this data set for what we're doing today is that it has lots of different kinds of variables in it that we can work with and use for examples. So this is the data set that we're using. And that's in, I do not want to save the changes. That's in the folder that I have set as my working directory. So now that I've set this as my working directory, how do I get this CSV file to where I can work with it in R? So this is our first R command that we're going to be looking at. So the way that I can read this is to say read.csv. So this is the command that's going to read it, and then I'm going to tell it the name of the file. Now, if you did not set your working directory, you would have to give it the whole path on your computer to find the file. But because my working directory is set to the one where we have the data, all I have to do is tell it the name of the file that I can see over here on the right, and it's madagascar.csv. Now, there's one more thing I'm going to have to do in order to sort of save this file in R so that I can use it. So I'm going to read this and show you what happens if I just run this. So I can come up here and press run with my mouse. Or what I like to do is I use a shortcut that's just on my keyboard. It's just Control Enter, and that will run it. But you'll see what happened when I just ran this and didn't do anything else. It put all of this data into my console, but I can't do anything else with it. It just basically read it and showed me what was in it, but I don't have it to where I can use it yet. So what I'm going to do is I have to name this, and then it will save it in this window up here. I'll be able to see that that's my environment. I'll be able to see it in my environment. So what I have to do, I'm just going to call this data set Madagascar. And so what I do is I put the name that I want it to have first, and then I use this assignment arrow. And this is really important in R. Anytime I want to name something or save some output, I need to use this assignment arrow. And all that is it is the less than and a dash. So that's just going to, now it's going to take this file, madagascar.csv, and it's going to save it as a data set in R that I can use called Madagascar. So I'm going to go ahead and run this line right here. And now you can see in my environment on the right, I have what they call a data frame called Madagascar. And one thing I can do with this right away is I can click on it. And you can see when I do that, it opens it up over here. And it looks very much like it does when I opened it in Excel. So I have all the variables, I have all the values, and I have all my 55 different individuals in the data set when I scroll down. And I'm going to assume that you're basically familiar with what data look like and variables and observations at this point. So, but now I have it in R, and now I can use it for things. If you have an Excel file instead of a CSV, there are a couple of things you can do. One is you could save it as a CSV, or we can read directly from the Excel file into R. And I think it's worth taking the time to show you how to do this because that's also very common. I do have another file, if you look over here, that is madagascar.xlsx. So this is a different version of this file. If I want to read from that Excel file, I'm going to have to first download a package for R. So there's a couple, this command here, read.csv, that is part of R from the moment that you put R on your computer. You can do that. If I need to do something, though, that R can't do, as soon as I put it on my computer, I need to download a package. Okay, so R has a lot of packages. They're available online, so you do need to be connected to the internet in order to do this. I'm just going to show you, and then we can come back and look at the details. So in order to read Excel files, you're going to need to download a package. And the way that we're going to do that, I'm going to write install.packages. So that's the code that we need to use to do that. And the name of the package is readxl. This is kind of an issue with using R, and I believe it's sort of the same for Python. If you need to do something that you need to download a package, you kind of need to know in advance what package you need. There's nothing obvious that tells you what package you need, so you can either search the internet. If you're like, hey, I want to read an Excel file, but I don't know how, you can Google package for reading Excel files in R, or you can ask someone who knows. So you have some great instructors and people who are available to you there that you can ask if you need help figuring out what package does something. But this is what we're going to do. I know the package that I need is called readxl. So I'm going to go ahead and click run. Okay. And you can see it gives me some messages down here that says it's installing my package. It says it was successfully unpacked, and it tells me some other information. If it doesn't work, you'll see an error or a warning down here in your console window. So now I have this package on my computer. I only have to do that part one time, but I still can't read an Excel file because the package is on my computer, but I can't access it in R yet. So in order to do that, I have to use the library command. And all I have to do is say library, type in the name of the package, and I don't get any message at all down here. If you're used to software that gives you a lot of messages or always gives you output, this can be confusing because it didn't say anything. But in R, a lot of times when a package doesn't say something, or when you do something and you don't get any messages in the console, that usually means it worked. So now I have the readxl package loaded into my R session and ready to go. So I only have to do this once, install packages. But every time I open R and I need to use a package, I need to do this. I need to library a package that I need to use. Why is that? A lot of people are annoyed that they have to do this every time. But I think the reason is if you have used statistical software that comes with everything, you'll know sometimes it can take a very long time to load into R or load into your computer when you open it. It can take a long time to open because R doesn't automatically open every single thing that you have. It opens faster, and then you can choose which things in R you want to have. So that's kind of the reason that it does that, is so it doesn't take a long time to load every time. All right, so we're going to speed things up just a little bit now that we've seen we've seen how to read a CSV file. We've seen how to install and load a package into R. We've seen setting your working directory. We've seen making comments. So we've already accomplished quite a lot that you'll really need to do every time you use R. Now I'm going to show you, though, finally how to read in this Excel file. I'm going to call this file Madagascar2. So remember, we type the name that we want it to have first. And then now that we have the read Excel package available, the command to read an Excel file is read_Excel. And I'm going to say Madagascar.xlsx because I can see that's the name of my file. And I'm going to read it. And I don't get any information. And I can see up here that it's now loaded in, and it's the same file, just from an Excel format. And so there it is. And both of these files can now be used in R. All right, so now we're going to get to kind of the goal of today's lecture, which is to do some basic statistical analyses. So I'm assuming you have some familiarity with basic statistical analyses, and I'm just showing you how to do them in R and how to get some useful things from them. So the very first thing we're going to do, so remember I'm going to open this up in the background. We have some demographic variables here about the individuals in this data set, and one of them is age. So we're just going to get some very simple statistics related to some of their demographic variables. So one of the first things that we always learn to do in a statistics class is to learn how to take an average. So what if I want to know the average age of a person in this data set? Well, I can do that just by asking for the mean of their age. But let's talk about how I tell R what variable I'm looking for. So I'm going to say mean. That's the command in R to get an average. But how do I tell it I want the age variable in the Madagascar data set? The first thing I do is type the name of the data set. So that tells R that I want to access something in the Madagascar data set. But then to identify a particular variable, I have to type the name of the variable. Now, this is one way that RStudio is very helpful. You'll notice when I started typing this that I got this list of variables that popped up. This only happens in RStudio and maybe some other software that's out there, but it doesn't happen in the basic thing you get that comes with R. So if I can't remember exactly how I spelled something, this is very helpful. But I'm looking for age, and the more I type, the more that narrows down what's happening. So that's really helpful. So I'm just going to type mean, and then I list the data set, and then I use the $ to say which variable I want to take the mean of. And there's the answer. The average age of a person in this data set is 41.43 or 44 years. Now, this is a lot of decimal places. I probably don't want that many decimal places when I ask for something like this. So there's an option in R to do this. This is called a global option in R to set the number of decimal places, or to set the number of places that you have. So I'm going to change an option in R. It's not specific to what I'm looking at, but this is going to set the default. And I'm going to say the option that I want to change is called digits. So I'm going to write options to change it. And then I'm just going to say in parentheses, digits equals 4. And that'll change it. And I can run this again. So I can always go back up to another thing in my syntax and run it again. And now that I've done that, you can see that it left it at 4 total digits instead of giving me all of the decimal places there. And I can always change that again later if I don't like the number of decimal places. So there's a lot of other things that we can do here. I may not go through all of them because you're probably familiar with them, but so other than mean, I can ask for something like standard deviation of age. So the standard deviation is 13.26. I can ask for a median. And there's a lot of different things I can ask for just by using commands that you probably would think would be the ones you would use, like min, max. I can do all of those. But what if I want multiple statistics? Usually I don't want just one statistic. Usually I want a set of summary statistics. So this is another example of where I'm going to use a package that can do that for me easily. And this package was designed to analyze data in psychology, but the name of this package is the psych package, called psych because of psychology. Now, I already have this, so I'm not going to go ahead and install it, but you will install it the first time you need it. And then to actually use it in this session, again, I'm going to use the library command. Now that I have this, first of all, let's see if I can do this package. Let's see if I can. I don't know if it'll let me look up help on an entire package. Okay. So if you want to know about something in R, usually the internet is a better place to look it up. Google packages in R, and you'll usually find more helpful material. But a lot of the things have their own help files associated with them. So if you want to learn more about the psych package, for example, I just typed in help and psych, the name of the package in quotes, and there is a help file that came up in the help tab over here. So this can tell you about a lot of things that the psych package can do. And so it describes it as a package for personality, psychometric, and psychological research. So it has a lot of functions in it that are going to be very helpful for that kind of research. But one of the things that it has in it is a command called describe. And if I want help on that specific command too, I can always do help describe. And this tells me what describe can do. So this is very useful, at least for getting some basic help on some of the things that you're going to be using. Again, it's sort of an issue that I have to already know what I'm looking for, and I have to already know what package I'm trying to use. But this can tell you some things about that package and some of the things that it can do. And I usually find details is helpful. Sometimes they have notes, and at the end of the help files, they have examples that you can look at to see how people write things. So the whole goal here was, what if I wanted a lot of summary statistics at once about the age and not just asking for them kind of one at a time? So I'm going to use the describe function in the psych package, and I'm just going to say describe Madagascar $H. And you can see that gives me a bunch of summary statistics at one time. So there's 55 individuals. The average age is 41.44. The standard deviation is 13.26. There's the median. There's some other statistics, like min, max, skew, kurtosis, lots of things all at once. And what you're seeing now, the way that I'm approaching these commands or these functions is that they all look kind of the same, right? I put the name of the function, so the thing I want to do. So function. And then in parentheses, thing I'm using. So this is what it looks like pretty much every time I want to write a function in R. Is you put the name of the function, and then in parentheses, you add the thing you want to run the function on. So now we're going to really do some, so we're going to look at, so the way that I've lined up the workshop is we're going to start by looking at simple summaries, so things we would call univariate summaries. And these kinds of summary statistics here, these are used a lot for numeric variables, things like age, that you want to take an average or a median or things like that. We also have some categorical variables in our data set, and we use different kinds of summaries for categorical variables. So we also have, I think a good example was we asked, or the researcher asked the people in Madagascar why they moved to the city. Why did you move to Vava Tanina from your original home? And so people gave reasons that they moved. And I can create a table just by using the function table. And if I want to say, just like I did with age, I type in the name of the data set, and then the variable I want is called reason for move. I'm going to run that, and here's that table. So this is a very basic table. It just tells me how many people in the data set gave each specific reason for moving. So I can see 15 people said that they did this for education, 13 said family, 10 said other, and 17 said work or money. So what though, a lot of times I don't just want numbers, I want proportions. I want to know what percent of the people in the data set said they move for a specific reason. So in order to make some of these things easier, I'm going to first save this table as an object. So I've got data sets that I've saved, but you can save other things too in your environment. And the general term we use for this is R objects. So my data sets are objects. I'm going to save this table as a different object, and the way that I'm going to do that, I'm going to call this move table. And I'm going to do that the exact same way that I save a data set. I'm going to put the name in front, use the assignment arrow, and now you can see it's saved over here under values. And if I write move table in my syntax, and then I just run that one line, now it has saved it and it will bring it up every time. So why would I want to save a table and be able to access it? Because this lets me see other things about that table. So I mentioned that a lot of times we want things like proportions. So if I want to see what proportion of individuals moved for each reason, there's a command called prop.table. And all I have to do is put the name of my table in parentheses next to prop.table, and now I can see the proportion of individuals who move for each of these different reasons. So, and what if I want percentages? Well, I can easily, what is a percentage? A proportion multiplied by 100. So here's an example of something really easy and straightforward that I can do. If I want to see those percentages instead of proportions, I can just multiply them by 100. Multiply the whole table, and it knows what I want to do there. So I can see 27% of the people move for education, 24% move for family, and 31% move for work or money. Everyone else move for a different reason. Okay. So that's the kinds of summary statistics we do for one variable at a time. Just a reminder, we looked at summary statistics for numeric variables, and just now we looked at how to make a table for a categorical variable. As we get more detailed though, a lot of times we want to see things that summarize two variables together. So summarize relationships between two variables, and we would call those bivariate summaries. I think before I do that though, I think I want to just pause and check in to see if see how things are going on your end. Does anyone have any comments or questions or things you'd like to let me know about how it's going over there? I'm having a hard time hearing.
Doctor, there's a question. Thank you.
Okay, great.
Doctor, thanks so much for your lecture on R.
Of course.
It has been intellectually stimulating. However, how would you convince someone that is conversant with the knowledge of SPSS to hurriedly switch to R language, recognizing several commands that one must be very, very careful with? Are we switching to R language because it is trending? Or we are gradually rejecting the SPSS? Thank you.
Okay, you're welcome. So I can comment very directly on this because, well, I used SAS originally. That's different because it's still programming. But the main reason I ended up switching to R was I left my university. And I didn't have anyone else to pay for SAS. And the same thing applies to SPSS, right? SPSS, you now have to license it or have a subscription to SPSS where I live. And so R is the biggest advantage in that sense is that it's free and I don't have to pay for it. So that's always the first reason to switch to R. It's not necessarily because it feels easier or because it's easier to it's not really more accessible to be honest. But there are other reasons to switch to R, and I think I understood those better after I switched. And I honestly, I do subscribe to SPSS because of some of my clients feeling comfortable with it. But I think what makes R, why would I argue with someone they need to switch to R? I think one reason is because SPSS is limited. It can't do everything that R can do, even right out of the package. SPSS doesn't have all the features and can't do all the things that R does. And there are some things that you can do if you learn to program in SPSS that you can't use the menus for. But even if you learn to do that, you still can't do everything you can do in R. So if you need to do some very advanced things, you're going to need to switch to R from SPSS. I think for me personally, another advantage of R is, and everyone always says this, once you learn to program, as opposed to clicking through menus and using the menus to understand everything, it feels easier. It does take a while, though, to build up to that level where you feel comfortable programming. But once you do, it feels easier and more convenient than having to take your mouse and click through all the menus and understand what it is that SPSS is asking you for. And I think one final reason that I might switch to R is there's only SPSS is only going to allow you to have certain options, or it's only going to show you things in one way. Because R is open source and anybody can contribute to it, new things come out faster. There are people who will program things so you can look at things in different ways. And if it's not available in SPSS, then you're just out of luck. So I think those are my arguments for at least learning to use R and having it available to you, maybe in addition to SPSS, but having it available to you as a tool. So
Thank you.
you're welcome.
I'd like to know if R is also case sensitive as
I'm having a little trouble hearing you. I don't know if you could come a little closer to the microphone.
Yeah, I said I'd like to know if R is also case sensitive as Python.
R versus Python?
If R is case sensitive as Python.
Oh, is it case sensitive? Yes, that's a great question. So I'll just show you right now. Let's say I try to do prop.table and I don't use the right capitalization there. Oh, it changed it for me because RStudio is very helpful. But if I try to just run it, it will say it didn't find it. Or if I say prop.table and I don't use the lowercase, then it will tell me that it couldn't find the function. So it is very case sensitive. And it's the same way when it comes to looking at variables in data sets as well. So yeah, it's very case sensitive. It's a good question.
All right, thank you, Dr.
Okay, you're welcome. Let me go ahead and show you some more bivariate analyses, and then I'll pause again to get some questions because those were good questions. Okay. All right, so let's move on. Again, bivariate. So I've shown you some things that summarize just one variable at a time. which can be helpful, but a lot of times we're interested in relationships. And so before we move into actual inferential analyses, I want to just show you some things that summarize relationships between variables. So one of those things is correlation. So that's used between two numeric variables. And there are several ways that you can do correlation. So we're going to, though, use a very simple command that's, command. We're going to use core, C-O-R. I use the term command, and sometimes I use the term function. Function is probably a better term for R, but you can also think of it as a command. Okay. All right. So COR is the command to get a correlation. And one thing that I wanted to see was, it's called Madagascar. So I wanted to see if there was a correlation between their current age and the age that they migrated. So are younger people, did younger people tend to move when they were younger or older than older people? So generationally, how old were people when they moved to the city? And so if there's a relationship there, we could try and find it this way. And when I do, so I just put in my two variables separately. And so in this, I think this is the first time we've seen a function that we can give two pieces of information to. So the way that we use correlation is we put in our first variable, then a comma, and then our second variable. And when we run that, we see a correlation of negative 0.1325. So if I want to take a second and look at the help here, move this out of the way. If I want to take a second and look at the help for the core function, we can see that there are some different methods that we can use. If I don't give it a method, it's going to give me a Pearson correlation. But I can also ask for a couple of other types of correlations, Spearman, Kendall. So if I don't tell it anything, though, it's going to default to Pearson. And let's talk about this correlation briefly. It's a small negative correlation. So this means that people who are currently older as they're being interviewed tended to be younger when they moved to the city. People who are younger tended to be older, but this is not a strong correlation. This is a small correlation. Okay, so now though, what if I'm like, maybe a Pearson correlation isn't appropriate. Maybe I want to see a different one. I can change it to, from this help file, I can see I can use an option called method. So I'm going to say method equals, and then I'm going to pick Spearman. And so if I want a different type of correlation, I can use, there's a couple of different methods I can use with the core function. And finally, in addition to correlation, we can look at covariance. I find correlation to be more helpful generally because it's easier to understand right away because we know that it's on a scale from -1 to 1. But if we understand the scale of our variables and we want to look at covariance, we can do that with cov. Age and age at migration. And so the covariance between the two is negative 11.41. All right, so that's a very common bivariate two-variable summary when you have numeric variables. If we want to look at categorical variables, we usually like to see two-way tables. So what if I want to look at reasons for moving by gender? So I want to know if males and females tend to have different reasons for moving. So it's very easy to make a two-way table. Oh wait, I want to do table. So I don't even need to use a different command. I can take the same one, table, and just put in my two variables instead of just one variable. And I'm going to say reason for move and gender. And if I look at this, so this gives me, again, I just said table, so this gives me numbers. Numbers aren't necessarily as easy to understand as proportions, but this does give me something that might help me get started. So I can see that for females, 4 move for education, 11 move for family, 7 move for other reasons, and 10 move for work or money. Among males, 11 move for education, 2 move for family, 3 move for other, and 7 move for work or money. So one quick thing I can do and just look at this is to say, okay, the most common reason for moving for females was family. The most common reason for moving for males was education. But what if I want to see some more things like proportions? Well, one thing I'm going to do is I'm going to save this table as an object. I'm going to call it move by gender. So I have it saved as an object, and you can see it over here. It's now here under values. And I can start just by saying, just like I did before, prop.table, and put in the name of the table. So this is okay, but it just tells me overall proportions in the data set. So, you know, I'm going to actually go ahead and multiply this by 100 because I like talking about percentages. So 7% of the people in the data set were females who moved for education. 20% of the people in the data set were females who moved for family. And so this is okay, but it doesn't help me compare males and females because it's still just looking at overall proportions. Okay, so then I can do more things to be helpful with that. Instead of just saying prop.table, there are options I can use to say, just give me marginal proportions. What do I mean by marginal proportions? I can ask within education, what proportion are male and female? I can ask within female, what proportion move for education? So the way that I do that, I can just put in a comma, and then, so let's look at the help for prop.table to help us understand what's going on here. So I say prop.table, and there's something called margins. And if I look at the explanation of what margin is, it says it's a vector giving the margins to split by. E.g., for a matrix, 1 indicates rows, 2 indicates columns. So if I say 2, I'm asking for column proportions. So let's go back and look at this. All right, so what have I got now? This is a, oh, and I should mention this because sometimes, like back up here, I said method equals Spearman. Down here, I just typed 2. I can say margin equals 2, and that's the exact same thing. It's better, like here I said method equals Spearman. I can remove method. Oh, it doesn't like it. So basically what you'll find is that it depends a lot on the order in which the programmer, the person who created R and created this function, the order in which they have put in the options, and it depends on how they did it, whether you have to type this or not. You can always type it, so it's always safer to type it. It's safer for me to say margin equals 2, but because I know R, I'm familiar with the situations where I have to type the option and where I don't. So you'll see me sometimes do it one way and sometimes do it another way. But you can always say method equals Spearman, margin equals 2. And I'm seeing that again here in this help file. So when I say margin equals 2, and I look at the proportions of this table, now I have proportions within the columns. So I can more easily compare females and males now. And I can see 12.5% of females move for education, 47.8% of males move for education. I can see when it comes to work or money, the proportions are about the same. It's about 30% for both males and females. So this is a helpful function as well. And if I want to see the other way, I can say margin equals 1. That'll give me row proportion, so I can see within education. 73% of the people who said education are male. This is more useful if I have equal numbers of males and females, and in this case, I don't. There's more females in the data set, but different ways that we can summarize two categorical variables together. Okay, and then the final bivariate summary that I wanted to share was for when you, so we've looked at correlations for when you have two numeric variables. I've looked at two-way tables for when you have two categorical variables. And now what if you want to look at a situation where you want to see a relationship between a categorical variable and a numeric variable. And one way that we can do that is to look at summary statistics for different groups. So just to give you a couple things we can do. If I just want to look at one statistic at a time, I can use the function by. And what I will do is I'm going to put the variable that I want to summarize first. So let's say I want to look at ages of males and females in the data set and see if they're the same. I can say, put in my variable age, then enter my variable gender. And then I have to do one more thing. So I can say by, so this says look at age by gender is kind of what I'm telling R here. And then I have to tell it though, what do I want to look at? And I want to look at a mean, let's say, so I have to add that function there at the end. When I do that, it'll show me the average age for the females in the data set was 37. The average age for the males was 47. So there was about a 10-year difference there. What if I want to get more descriptive statistics? So what if I want a complete summary according to gender? So then there's a function, and this function, this is just another way to use the by function. I'm actually going to copy this. If you remember, when we had the psych package, we had the describe function from that package. Now that I have the psych package loaded, I can just use describe from that package in this by function. So now you can see that I have descriptive statistics for females and I have descriptive statistics for males. So we have covered now looking at relationships between two numeric variables, looking at relationships between two categorical variables, and looking at relationships between a numeric and a categorical variable. All of these so far, though, have just been summaries. And what I want to spend the rest of the time doing, so as much as we have time to get through in the next 40 minutes, is I want to look at some inferential statistics. So these are statistical tests. And again, I'm going to assume that you are basically familiar with the tests